Hello, this video is about pandas, okay? You might be wondering, what are Python pandas? And just for giggles, I typed in Python panda into a couple of AI art generators and I got, yeah, wow, Python pandas. Are we talking about a mutant hybrid, like a panda with scales? No, but it would be cool if we were, right? No, pandas is a Python module or library that you can use to analyze and clean and correct and manipulate and get statistical information on data sets, okay? The name comes from panel data, so PAN from panel, and then DA from data, hence panda. That's where the name comes from, but it is also kind of cute to think of like a little Kung Fu panda or something, right? A cute little panda. But panel data, it's a term for data sets that include observations over multiple time periods for the same individuals. And you can write your own functions and your own methods to emulate what pandas do, but why reinvent the wheel? Pandas offer such an amazing suite of, just different functions and ways to manipulate, powerfully manipulate data and transform it and do all sorts of things with it. So why reinvent the wheel if you don't have to? Why not use pandas when and where they apply? So just a couple of things. You may need to install the pandas module using pip if you haven't, okay? So let's see what version I'm using. Currently, I'm on version 3.10.9 and I'm using Anaconda. And let's list my modules here. Okay, so my current version of pandas. Okay, 1.5.3 is my current version of pandas. But just in case, odds are, if you haven't been using pandas, you may not have this module installed. So let me make my environment like your environment is currently, okay? And I'm just gonna uninstall it. Okay. And then I'm just going to close and reopen Visual Studio Code so that we can see what you might be looking at right now if you're trying to import pandas and wondering, why do I have the little yellow squiggly line and why is pandas not there? And pretty much with any module that you pip in or import, and by the way, I need to run Visual Studio Code as administrator. If I don't, it never completes the update process. So, all right. I don't know where my little yellow squiggly line has gone, but you might be, if that's what you're seeing here, and you're trying to run something using pandas, then there we go. Just took Visual Studio Code some time. So see, it can't find that module. And that, if you haven't been using pandas and you haven't installed that module, that library via pip, this may be where you're at right now in your Python development environment. And that's fine. So all we need to do, we just need to get that package, right? And we can use pip and make sure you run as administrator. I could, if you set up your Visual Studio Code, you could run it from here, but in this case, you need to have administrative privileges. And I've opened this administrative command prompt. So pip install pandas. All right, just 3 words. And let me scroll up here. There. Okay. And so you'll be doing this, right? You'll be pip install pandas. That's what you want to do to get the library, get the module. Okay. And then you should get successfully installed pandas. Okay. So, and then let's see what version I got now. 201. Okay. All right. So that's quite a leap forward. So let's see if you can get version 201, right, of Pandas. Okay. Now, when you do that, right, when you add any module, you install an additional library using pip, and you've got a project open in Visual Studio Code, you need to close down Visual Studio Code and reopen it so it can then reconnect to Anaconda and the Python interpreter to be able to access that module or that library. So I just need to close down Visual Studio Code, and then I need to, let's reopen it here, and I'm going to run as administrator so I don't get I don't have permission to update error when I close Visual Studio Code if you don't run it as administrator. And now, give it a minute to load here. Okay. So now notice that our little nasty yellow squiggly lines are gone now. Now we can access Pandas. Our first function, we're just going to check the version. And so whenever you use Pandas, you're going to want to import it. So import Pandas, and then I'm using an instance in this case. I could directly use the Pandas module, but I'm going to use an instance that I'm going to call PD. You could call it anything you want. You could call it supercalifragilistic if that's your preference, but it's traditional to call it PD. That's just a variable, just an instance name, an instance whereby we can use the Pandas module. And so with that, I'm going to call version. I want to get the version attribute, and if I do that, I'm going to hit F5. I'm going to run this. And this is just testing whether or not we can connect to and use the Pandas module. And see down here where it says 201? All right, so we can connect to and we can make use of our Pandas module. Now we know this. And I'm going to resize this a little bit because my display, it's kind of going off the screen there, and I don't know whether or not you guys can actually see what I see. So I'm not going to, let me just resize this a little bit. I'm going to be sure that you guys see what I see. There we go. Okay, so I'll run it again. Okay, so 201. So we know we're connecting to our Pandas module. We can get the version, all that good stuff. Okay. So let's go through our first example with Pandas here. Our first real example. And that is this function here. Okay. So here we have a dictionary, okay? And we've got silence, and we've got threat level, right? So we have two keys, and the values stored. For silence, we have a whole list of values, a list of strings, and they're just names. I don't know if you guys ever watched BSG, that series that was out years ago. One of my favorite science fiction series, but there were all these, you know, these quote people who look like humans, but they were really silence. And part of the wonderful thing about the show is this mystery, and that they kept you in suspense of finding out, you know, who's the Cylon. You don't know who's the Cylon. There are all these Cylon sleeper agents. But so we have 6 names. These are the names of 6 Cylons in that series, BSG, Battlestar Galactica. And then there's some imaginary threat level. So just key value pairs. And in our dictionary, we've got, you know, lists for values. And this would be the key name. So what we can do is we can take this and we can load it into what's called a Panda data frame, okay? And a data frame, once we do that, we can manipulate that dictionary. And we can do this with all sorts of objects, dictionaries, lists, all sorts of things. But so we take our dictionary, we're going to load it, pass it into as a parameter to the constructor for a data frame object. So pandas.dataframe. And here, I'm directly using the Pandas module. And you can do that. Alternatively, I could do this. I could create an instance, and I could do that. And we'll do that in other examples. But just to show you that you can directly use the module, all right? So we do that, and then threat analysis is sort of our variable. right? Our little pointer that points to that object in memory. And we're just going to print the result of that. And Pandas just, you can do all this formatting manually. And I still think we need to know that when we're dealing with console apps and writing console apps. So I'll probably do a video on that. But the great thing about Pandas, it does it all for you. I mean, it does so much for you when it comes to displaying the data in neat columns, rows and columns fashion. So I can just take this dictionary, pass it into a Panda, and then use the Panda functionality to display it. I'd have to add, several lines more of code if I was going to manually format those rows and columns. And yeah, we'll look at how to do that in a later video, but since this video is about Pandas, isn't it nice that we can do it automatically? So let's run this function, F5. And see how it formatted our data, cylons and threat levels? We have 2 columns of data, and it's just based on the key values in our dictionary. And then we've got automatic rows here. Cavell, Leobin, Diana, Simon, Aaron, Six, Sharon, and their threat levels are all displayed nicely. And I didn't have to use any formatting code. I didn't have to add extra lines to, and I could have spent 10 minutes playing with spacing and characters to figure out how wide to make my columns and how to do my rows and things like that. But I could do that, or I could just use Pandas. And Pandas, it's like magic. It just takes care of that formatting for us. Why reinvent the wheel if you don't have to, right? In this next example, we're going to do the very same thing we did before, but we're just going to do it a little bit different way. In this case, instead of using the Pandas module directly, we're going to import it as an instance. So PD, sort of a traditional, but you could call it banana if you wanted to, it doesn't matter, but PD, and instead of using the module directly, we'll use our instance. Same thing, we're going to instantiate, build a data frame object. As the parameter, we'll pass into the constructor our dictionary. Our dictionary is similar to the one before. We have hidden leaf ninjas is one key value, and chakra levels is the other key value. And then we have some lists, so an entire list of strings here. And we have an entire list of chakra levels here, okay? There's our dictionary. We pass it in, and again, if we were going to do this manually, we could spend 10 minutes trying to figure out just how many characters wide to make each column and how to format it, and we'd have to change it and run it, and change it and run it, and change it and run it, and change it and run it until we get it to look right. But why reinvent the wheel? If Pandas can do this for us, we'll use a little Pandas magic and save ourselves some time, right? So if we run this, let me hit F5. Okay, and again, notice our columns have been formatted. So our chakra levels and our hidden leaf ninjas, Naruto, Jiraiya, Kakashi, Hinata, Sakura, Sasuke, Kiba, and Akamaru. And then here are their chakra levels. But we didn't have to worry about formatting because Pandas took care of that for us. In this third example, let's take a look at adding headers, all right, using Pandas. And to add headers, we'll just use a list and specify the header names, okay? So first our data, right? We import Pandas, and then we have a list here, and it's got some different data types, integers and strings, okay? That's our data. Here is our headers, another list, how we want to label the table, okay? And then I'm just going to show 3 different ways to do this, all right? So Pandas data frame, it's the same syntax in A, B, and C. But for horizontal tables, we always pass in the pony data first, regardless, A, B, and C. Whether it's horizontal or vertical, it's always going to be the in this case, the list object that we created, right, with our data frame, that we added to our data frame via the constructor. But then look at the position of none here in this example, right? So the list that has my header labels, I add it last. It's the third parameter if I'm doing horizontal labeling for my table, okay? For my Panda table. So it's the third parameter. And none is number 2, but the headers is number 3, the last argument. But if I want vertical, instead of horizontal labels, then my headers would be not my third, but my second argument, and none would be third, okay? And then in this example C, if I wanted to do, for some reason, horizontal and vertical, then I would add headers to both, and I wouldn't use the none argument at all. So let's run this code, and I'll pull this up here so I can try to give us try to display everything at one time if it's possible. Let's hit F5 and run it. Give us a little more screen real estate there. Okay, and is it possible I can... Is it possible I can get all this output here? There. Alright, so A, B, and C. And then up here, okay, so the first time through, right, horizontal panda tables. Again, look at the position of the list that contains my labels for horizontal. Alright, so that list was defined up here, right? Position, team, win, lose. Here it is. Position, team, win, lose. So it's horizontal labels in my table. And then the pandas, the panda takes care of all the formatting, you know, the columns and the rows and everything, and applies my labels. The next example where I did vertical, okay, so instead of passing my headers list in as the third argument, I pass it in as the second argument, right? And so now look, position, team, win, lose. Here, it's vertically labeled instead of horizontally labeled as it was in A. So B is vertical, A is horizontal. And then if I wanted to do both, look right here, I pass in the list of my labels to both, right? Horizontal and vertical. And look what happens now. Position, team, win, lose, horizontal, and position, team, win, lose, vertical. All right. So that's just an example of how to, how to make use of custom labeling with your Panda tables. So we've taken a look at basic pandas and a Panda table. Now let's look at Panda series, okay? You can think of a Panda series as an instance of a single column of data inside of a table, okay? If no labels are specified for a Panda series, then they can be numbered automatically by the index subscript value when you display the Panda. So let's look at our code. Again, we're going to import pandas and create an instance of it called PD. And then here we have a list called the TNG cast. It just consists of some strings, okay? Picard, LaForge, Worf, Data, Riker, Crusher, Troy, the main characters from Star Trek The Next Generation. And then here, we're just going to display a Panda series labeled by index values, okay? So no labels are being supplied for it, so it will simply automatically be displayed by the subscript value, 0, 1, 2, 3, 4, and so forth, as it iterates through and counts the items in our list, okay? But now in this second example here, we create another list, we call it TNG headers. We're going to pass that in as an argument after our data. And so instead of being labeled automatically by the index subscript value of the elements in the list, it's going to use our custom labeling here. And it's just that easy to create and format a column of data using a Panda in series. So again, here's our data, TNG cast, that goes in as our first argument, right? When we instantiate or create our Panda data frame. Then our next argument, TNG headers, that's our labels. We pass that in. And finally, the third argument is just none, okay? So let's run this and see what happens. We hit F5. And so again, here's our vertical labels here. So Captain, Picard, Engineer, LaForge, Tactical Worf, Science Data, First Mate Riker, Dr. Crusher, Counselor Troy, right? So those are our data values. Let's take a look at another example here of using a panda series. And here we have a list consisting of a Fibonacci sequence. And that's a very interesting ratio or relationship that it just appears in our reality. It governs the formation of galactic superclusters at the macroscopic level, all the way down to things like seashells, the spiraling seashells or snail shells, and the way leaves grow on trees, all the way down to things at the microscopic level. So it's very interesting, the Fibonacci sequence and series of numbers. It's also called the golden mean or the golden ratio because it's made use of so much within the structure of nature itself. But let's say that we had a list with the Fibonacci sequence of numbers, and we're going to instantiate a panda here using our instance of our panda module, PD, a series. We're going to pass in our list, right, our Fibonacci sequence, and we're going to use golden ratio as the variable or the pointer to hold on to that in memory and to get to it, access it, manipulate it. Okay, and we're just going to display the whole panda series at once. And then we're going to iterate through, and how would we display one element at a time? It just uses array subscript syntax, just like you would with a list, right? Just like you could with any type of iterable. You could specify a subscript value, an index. And so if we run this, let's hit F5, and we'll see what happens. Okay, so here we display our entire, a single column of data. That's our panda series, and it's our Fibonacci sequence, and it's just labeled by the index subscript value. There's 10 numbers, but remember, it's that fence post issue. It's off by 1, so it's labeled 0 through 9, not 1 through 10. Okay, the entire series at once. And then how would we access each element individually? Just using the square brackets and that array subscript index syntax that you would use with, like, say, a list type object or other iterables. So element 0, 0, element 7, 13, all the way down to our last element. Just illustrating that, all right, how you would do that. Let's take a look at our next example. So here we're importing pandas as an instance, PD, right? We have a list, and it's for transporter coordinates. So maybe for Geordie LaForge, if you're a Star Trek The Next Generation nerd like me. But so beam target, this is the variable, right, or the pointer that will point to a pandas series object that we're going to build, and we'll instantiate it with these parameters: the list that we want it to format, and then the index. In this case, this is just a quick and easy way to label. If I specify this as my second parameter, index equals, then I'm going to set up the label for, in 3D space, you have an X and a Y and a Z coordinate, right? So we would assume that the transporter, that, Geordie would need to know those coordinates, X, Y, and Z, to be able to target that person and reassemble that person in the right place in space-time, okay? So X point, Y point, and Z point for a 3D coordinate. Enter series at once. Well, I can display it all at once with my custom labels that I used with the index parameter here, the index option. And then I can also display it by label. I can display the data label by label. So let's take a look at that. We'll run this example. Hit F5. And let me pull this up here. All right, so look, the entire series at once, right? Beam target, and it's got all of our labels that we set up here using index, okay? So X point, Y point, Z point. We're assuming those are some coordinates to some awesome planet that they're, someone's beaming down to, right? And then how would we access that element by element? Well, again, using that array subscript syntax, but this time, instead of numerically indexing it from 0 to whatever the last element would be, we're going to use the label names. So X point colon, Y point colon, Z point colon, those are the actual label names, and I can get at the specific value stored at that label, that location, using the label name. right, so we've been using lists with our Panda series. Let's use a dictionary with our Panda series object. So here, let's say that we're measuring blood sugar, which is something I have to watch. Yeah, sugar's like poison to me. But let's say we were going to take a look at blood sugar levels, okay? So in this function, we're going to create a dictionary, blood sugar. And this will be 4 days worth of measurements of our blood sugar, right? So day 1, we're doing pretty bad. We're 300. That's too high. Normal blood sugar should be between like 80 and, let me close that there. Normal blood sugar should be between like 80 and 100. Okay, so 300, it's like 3 times what normal blood sugar should be. That's way too high. Day 2, coming down, but still way too high. Day 3, coming down, but still way too high. Day 4, coming down, but still way too high. So you better increase the exercise and eat less carbs, and maybe if you have to do a little insulin or metformin, who knows. But if you're a diabetic, you know what it's like, right? So in this case, we're just monitoring and recording our blood sugar levels, okay? We're going to instantiate and build a Panda series object. And we're going to pass in our dictionary as the parameter, as the argument to the constructor. And this variable here points to that, okay? So this variable points to our Panda series, and therefore we can use it, if we want to display the entire thing, the whole kit and caboodle, as they say. Or if I wanted to do it element by element, I could use array index subscript syntax, okay, in the square brackets, and I could go element by element. Day 1, 2, 3, and 4 would be indexed to 0, 1, 2, 3, right, because of the fence post, right? Remember that off by 1? Remember that? That's how it works with array or list or dictionary, any iterable type syntax, basically. But also some methods that I could call describe, and I could get data based on the dictionary that I passed into that Panda series object. Okay, all array access a specific element, from within my dictionary. In this case, the first one, right, with the subscript value. But here I'm just showing some series methods. And then down here, how would you get key value pairs? Well, to get the key, I would call sugar levels, right? That's the variable, the pointer that points to my Panda series object. And then I would use index, and I would pass on the subscript value, 0, 1, 2, 3. Then I'd get the key name. But to get the value, I wouldn't use index. To get the value, I would just use index subscript syntax on the variable that points to the Panda series object itself. Boy, that's a mouthful, but I tried to be a little bit accurate. So let's take a look at 4 categories of elements that have something to do with a Panda series object. So first, here under section A, we're just going to display an entire Panda series object. And all we have to do is use the variable that points to our Panda series instance, right? The one that we passed in blood sugar, our dictionary to. We can display everything all at once using just that variable, passing that variable into the print method. Next, we're going to look at, okay, if that's how you get an entire Panda series, what if you just want a particular element, right? A key value pair or a value from that dictionary that's part of that Panda series. Well, if that's what you want, you just use array syntax, right? You use array subscript index syntax, which is just a square brackets and then the number. And remember the fence post issue with array syntax. So if you have 4 elements, right? If I have 4 key value pairs, yeah, I do have 4 key value pairs, but it's not numbered 1, 2, 3, 4. It's numbered 0, 1, 2, 3. Okay, so remember that off by 1. But other than that, that's just the same syntax you would use with a list, right? Or any other type of iterable if you're using array subscript syntax. Okay. Next, down here in section C, we're going to call some special methods that are available on Panda series objects, okay? So we can call describe, and that'll give us all the data that goes with that Panda series object, and the all attribute and array, and we could specify a particular element, right? A particular key value pair using the index attribute. And again, notice it's that array syntax. And last, down here in section D, how do we do key value pairs if we wanted to explicitly call each one, each key versus each value? Well, to get the key or the label name right, the key from that dictionary that's in our Panda series object, we would use the index attribute on our Panda series object. So the name of our, up here, right, this is the name of our Panda series object, the variable that points to it. And I would use the dot operator and I call index, and just like any other iterable in square brackets, I pass in the array subscript value. On the other hand, if I wanted the value instead of the key name, I would not use the dot operator and index. I would use just the name of the Panda series object itself and then array subscript values, same as before. So if we run this, let's see what it looks like. And I'll hit F5 to run it. Okay. And so again, let's look at A, pull this down. We'll try to look at the code and the output and compare it to the output here. If I can get everything, okay. All right. So the entire Panda series object at once, that's A. And all we did was just pass in the variable that points to it, right? And look, here's all our data. Here's the entire dictionary formatted nicely by our Panda series object, okay? Next, how do we do it? How do we access these values element by element, okay? So if I want to do that, it's just in square brackets and that array index subscript syntax. So that's B here, okay? C, let's look at some special methods. What about describe? What does that do? Look at all the data we get from calling describe on a Panda series object. Count, mean, standard, minimum, 25, 50, and 75% maximum. A lot of data just at the snap of a finger by calling describe, right? Okay, and then let's look at the all attribute and array. If I call all, it just gives me all the key value pairs. See? There, all the key value pairs. Really, syntactically, it's giving me the same thing I got up here, but the attribute index, if I wanted to get at the very first key value pair, all right, notice that's down here, right? That's just day one. That's just that key. Now, last, how would we differentiate between the key name part in our dictionary versus the key, the value that corresponds to that key in our dictionary? Well, we do it this way, right? So sugar levels dot, and if I use the index attribute and a subscript value, that's going to give me the key. See, look down here. Key equals day one, key equals day two, key equals day three, key equals day four, okay? But if I use the same syntax, array, index, subscript syntax with the square brackets, but I do not use the dot index attribute, instead I just use it directly on the Panda series object itself, then I get the value. So that way I can independently retrieve the key name and then the value stored at that key using the same index subscript value of that particular element in my dictionary. Let's take a look at another example of using a Panda series object. And this time, let's say that we have a dictionary of key value pairs, but we only want part of the data in the dictionary. We don't want the whole thing. Well, you can create a Panda series based on a partial amount of data from a dictionary. So in this example, we have Betelgeuse luminosities, and they say that Betelgeuse, it's basically a supergiant star that's could potentially go supernova in our lifetime. It's nearing the end of its life cycle, and it's burned up most of its nuclear fuel. So the outward pressure of nuclear fusion is not enough to resist the gravity that will collapse in on itself, and eventually it'll go boom, supernova. So right now they say in the year 2023 that Betelgeuse is producing the luminosity of about 14,000 of our suns, okay? So 14,000 of our sun luminosities. Let's say that next year it produces 15,000 and 16,000, right? It's going to swell and get hotter and hotter before the big moment, all right? But before it goes supernova. So countdown to supernova, that's our variable name, will be a panda and series object, and we'll pass in our dictionary here, Betelgeuse luminosities, and our labels, right? We're using the index attribute 2023 and 2024, but let's say that for some reason we don't want 2025 data. Maybe 2024 is the year that, boom, of course it would still take, the light a long time to reach us from Betelgeuse. So but when we look at stars up in the sky, we're looking into the past, right? The light from those stars can be hundreds or thousands of years into the past, and it just took that long for light to reach us at 186,000 miles per second, velocity c. But in this case, let's say that we're just looking at luminosities, and we only want 2 of those years, because for some reason, say in the year 2024, Betelgeuse goes boom, and that's the supernova. Okay, so to do that, let's just use index, and we'll just retrieve these 2 labels here, and then we're going to display, right, our variable that points to our panda series object. So if I hit F5, okay, so year 2023, 14,000 suns, year 2024, 15,000 suns, okay? In this example, let's take a look at a panda data frame. So whereas a panda series is like a single column of data, a panda data frame is an entire table of data, all right? So it's like a 2-dimensional array, if you want to think of it, or a table with rows and columns, okay? Horizontal, vertical. So we have a dictionary here. We'll call it Pinkie Pie Productivity for her cupcake factory. Day of the week, 1, 2, 3, 4, 5, 6, 7, right? And then the number of cupcakes that she bakes or manufactures on each of those days of the week. And of course, she takes Saturday off. That's her day off. So what we're going to do is build or instantiate, instead of a series object this time, we're going to build a data frame object. So we take our instance of pandas that we've imported as PD, right? And we're going to build or construct a data frame object. And as a parameter into the constructor, we'll pass Pinkie Pie Productivity, right? That's our dictionary. We'll call it PPP data for Pinkie Pie Productivity, right? Triple P data. We'll display the whole data frame at once, okay? And then after we display the data frame all at once, how would we display a particular key value pair? Let's say I just wanted the cupcakes manufactured on a particular day. Well, again, it's that square bracket array index subscript syntax that we use with any other iterable type of object in Python, okay? So for that matter, C++ or PowerShell or Java, the same syntax fit. All right, so and we're going to use the location attribute, and we'll pass in the element, the subscript, the index value that we want to get at. So 0 would be the very first element, right? The key value pair, first key value pair in our dictionary. So let's say 1 and 444. Remember, we always start counting at 0, not at 1. So there's that fence post issue, okay? All panda data frames row by row. Well, here we're just going to create a for loop. We're just going to iterate through it using range and len and PPP data. And so we'll say we'll just number the rows, because with range and len, x no longer points to an element itself, but it just becomes an integer value. And then to get at the actual object itself, we'll use array subscript syntax and our square brackets, and we'll use the LOC attribute, right, the location attribute, and we'll display it. So we can do it this way with the for loop, but also just to show you, I could pass in an entire list, and in this case, the location method would take care of that for us. It would iterate through and display all those elements. 2 ways of doing the same thing, but this is a convenient shorthand way to do it. So let's run our method here. And we'll step through the code A, B, C, and D here. Hit F5 to run it. And let's scroll up to A here. See if I can lift this up here and get hopefully all of this Not easy. There, get all of this on the screen at one time. All right, so here's A. All right, so this is just displaying the entire data frame at one time. Keep wanting to say datagram, and that's not working, and my brain's got those two crosswords. If I say datagram instead of data frame, no, I'm not talking about a datagram or a protocol or packets or anything like that. What I mean is data frame. My brain is like short-circuited on that. Anyway, entire Panda data frame at once, we just have to pass it in, okay? So PPP data, Pinkie Pie productivity data, that's our variable that points to the data frame that we instantiated with our Pinkie Pie productivity dictionary, which has days of the week and the number of cupcakes that she baked or that she created, right? So in the next example, a single Panda data frame row, and that's using location, and I just use array subscript syntax. So if I want the first element, it's always going to start at 0, right? And then if I start at 0, I just pass that in to the square brackets. And look, here's day of the week 1. And how many cupcakes? 444, 444, okay? Next, let's go to C. All Panda data frames, row by row, via iterable for loop. So if I wanted to plug this, in this case, this data frame object into a for loop, I could do that, all right? So I could take my PPP data, which is my data frame, and just like an iterable, in a for loop, I could use range, the range method, the lim method to get the number of items, and the range. Remember, 0 starts at the default, and then I want to go all the way to the end to the number of items. And so I'll just display row. I'm going to add 1 because, yeah, human-wise, we count from 1 to the last object, but computer-wise, it counts from 0 to the last object. So we're just adding 1 to x here as an integer value to make it more human-friendly, more readable, right? And then here the location method, and then an array subscript syntax and the square brackets. So 0 to the last element. And look, what does it do? Row 1, row 2, row 3, row 4, row 5, 6, and 7, corresponding to the day of the week and the number of cupcakes baked. Okay, so just an example of using, in this case, a data frame object with a for loop and a repetition structure. And last, we're doing the same thing, but instead of 3 lines of code, well, we don't have our nice little line there, ASCII line, but still, we're approximating 3 lines of code. We're only using 1 line of code, and that's using the location method. And look at D. So our Panda data frame object, it generated the table for us, the rows and the columns, and labeled everything nicely. So why reinvent the wheel if you don't have to, Just wonderful functionality, wonderful feature of a Panda data frame object. Let's take another look at a different example using a data frame object. So scroll down here and comment this function and uncomment this function. Okay. All right, so here we have another example. And in this example, notice that our vertical labels in the previous example, they were automatically numbered by the index subscript value because we didn't supply a parameter to set specific labels on that data. Well, we're doing the same thing here, but now instead of using the default array index value, just numbering it 0 to the last element, we're going to specify our own custom labels, okay? And we do that as we did previously with the index option, passing that in as a parameter. And the list here, these are our headers, right? Header values are labels that we want to use in our Panda data frame table. So let's go do that. And here we're going to just display the entire table at one time. And then using the LOC method for the location, if I specify a label, Friday, well, these are connected. They have a positional relationship with the data in my dictionary. So if I specify Friday, what do you think it's going to display? Well, look, Monday, Tuesday, Wednesday, Thursday, Friday. So it should correspond to day 5, and then and our number of cupcakes baked and our values 1, 2, 3, 4, 5. So 851 on day 5, which is Friday. So let's run this. I'm going to clear the screen down here, hit F5 to run it. Okay, and again, look. So now all of our custom labels have been applied vertically, okay, to our table. And we still have our 2 columns, day of the week and the number of cupcakes baked by Pinkie Pie for Pinkie Pie's productivity, PPP, right? And if I wanted to specify a particular key value pair from that dictionary stored in my Panda data frame object, I could do that using the custom label. So look at the position, right? 1, 2, 3, 4, 5. Friday's at position 5, okay? And then look at here, day 5, right? That corresponds to 851. So see how it maintains a relationship inside my dictionary, relationship inside my Panda data frame object, relationship to my custom labels added to my Panda data frame object. And so if I specify that label Friday as a day of the week, then I can get at the 5th day and the number of cupcakes that Pinkie Pie baked for that day. Now, with Panda data frame objects, there's a default number of max rows that your system has set. And if your data set has more rows than the maximum number, then it'll simply return the headers of the first and last 5 rows, okay? So you can change that. So I'm going to display the default max rows, and then let's say that I wanted to change it to 9,999 if I was working with a large data set. I could do that. I'm going to run this, hit F5, and we'll look at the default. All right, so by default, it was 60. And then I changed it down here to 9,999. Python Panda objects have a built-in capability to read data from and write data to CSV files. All right, so in this example, we're going to look at opening a CSV file and then accessing the data and displaying the contents of that file. So to do that, we only need a few lines of code. First, we need to import the pandas module, and in this case as an instance PD, and then we'll call the read CSV method on our instance of pandas. We're going to pass in the name of the data file, and we'll just use the directory that the script is running in by default to keep it simple. So if we look at that directory, let's look at that directory here. We want to open panda CSV data. All right, so this file here, and I just created this using Notepad. It would be readable in Excel because it's a CSV, and Excel would load a CSV. But so with a CSV, the first row is going to be your field names. Okay, so think of it as your column name, or your variable name, or your field names. And then after that first row, every other row maintains a relationship with the first row in terms of columns, and that's your data. So our very first row would actually be Luffy, not this line here. This is our field names, our column names, right? But then after that, Luffy, Zora, Nami, Sanji, Chopper, Robin, Usopp, the cast of One Piece, if you're a One Piece fan. And then they have a name, attack, and defense values in our data. Okay, so this is what's in our CSV, and this is our file that's in the same directory as our Py file, right? As the script that we're running. Let's see what happens when we run this. I'm going to hit F5. Okay, and look, we read the data from the CSV, we loaded it into our Panda object, and then look how nicely Panda formatted it. If it weren't for Panda, that would all be loosey-goosey and random. You know, I'd have to spend a long time, a lot of trial and error trying to format out my columns by the character width and so forth. But look at all that the Panda object has taken care of for me. All right, no need to reinvent the wheel. So nice functionality, reading data from a CSV file. Let's close this file and let's look at another example using CSVs, okay? All right. So here let's use the head and tail method. And so if I call the head method, it returns a specified number of rows starting from the top. If I use the tail method, it's just the opposite. Returns a specified number of rows from the bottom, okay? So in this instance, under A, we call head, and we're going to read the first 4 from the top. In this instance, we call tail. We're going to read the last 4 from the bottom, just to illustrate. So same data, same CSV file, panda CSV data.csv, right? The same method to open it, read CSV, but now we're just using the head and the tail method and illustrating what those do. I hit F5 to run it. Look, all right? So from the top, Luffy, Zoro, Nami, Sanji. And if we open that file, right? Luffy, Zoro, Nami, Sanji. So those are the first 4 horizontal rows, right? Records in my data set that I read from the CSV from the top, okay? Now let's look here. Sanji, Chopper, Robin, Usopp. Well, again, let's look at our CSV. Usopp, Robin, Chopper, Sanji, right? These are the last 4, and these are the first 4. So, Sanji sort of overlaps there, but gives you an idea of head and tail. And that's useful when you're organizing your data or looking for a particular record or row in a large set of data. Let's take a look at another CSV example. Let's go up here and let's look at info, all right? If we call the info method, again, we're reading the same data. All right. So look at this. It's telling me in this case the data type, and it's automatically parsing and converting that. It reads all this in as string data at first, but then it takes a look at it and says, well, okay, name non-null, that's a string object, and then these are non-null integer values, int64. Memory usage, just get some useful data that way. In this example, we're going to take a look at Python Panda's ability to read JSON files and JSON data. Okay, in the same way that Python Panda can read and write to a CSV file, it can also read JSON data. It's just textual data, ASCII text, but one of the interesting things is that JSON syntax follows the same syntax that Python uses to define a dictionary and its key value pairs. So it makes it really good at manipulating JSON files and doing things with JSON data. So here we're going to create a dictionary to emulate a JSON file or JSON data, okay? And so we have a couple of keys here: health, attack, defense, and magic power, okay? And then this is sort of a two-dimensional because each of these keys has within it another key value pair. So for every class of character, let's say that this is for a game, right? Fighter, paladin, mage, monk, thief, hybrid. They each have a different amount of health, a different amount of attack, a different amount of defense, a different amount of magic power. A mage or a magic user would have more magic power than, say, a fighter, whereas a fighter would typically have a lot more strength, a better attack or so than a mage. Just how you might format a game. But this syntax here, this dictionary, it is pretty much how you would define a JSON file, except for my little semicolon here, which that's optional. You know that's just me. You don't need that in Python, but I just do that so I can add more than one line of code on a line, multiple statements on a line. And also, I just kind of bring that over from C++ and Java. It just makes it easier for me to follow the code and so forth. But aside from that, this structure here, this dictionary, that's a JSON file. How cool is that, right? So we can use that. We can plug that into a Panda data frame. So I'm going to take my dictionary JSON data, plug it in, and I'm going to display it, okay? But later, in this next example, we're going to take that exact dictionary syntax and put it into a text file and give it the extension .json, JSON, and believe it or not, that dog will hunt, as they say. That dog will hunt, it'll process, okay? So looking at this example, let's run this one first here. And using that dictionary, I'm going to hit F5 to run it. We'll display that whole dictionary, right? So look, fighter, paladin, mage, monk, thief, and hybrid. And then look, health, attack, defense, and magic power. Here's our columns, here's our rows, defined like a two-dimensional array, like a multi-dimensional array inside of our dictionary, right? So each key itself has a key value pair. It's just nesting. We're practicing nesting. Once again, a recurring theme in programming, isn't it? Whether you're dealing with repetition structures, whether you're dealing with decision structures, whether you're dealing with intervals, whether you're dealing with pandas, dictionaries, whatever. So in this case, we've created a nice table and we've displayed it. Well, in our next example here, let me go find this and uncomment it. Let's stop running this function. And now let's run this one. All right, look, here, in the same way we had the read CSV method to read data from CSV file, we have read JSON, and that'll read data from a JSON file. And a JSON file is just a great way to create an external configuration file. It's used in several different programming languages, lots of applications there. But look, we're going to read the JSON file. We'll store it in our data frame. Here's our Panda. And then data frame to string, we have to parse it. Again, we have to typecast it to a different data type, to a string, so we can use it with the print method. But I want you to look at our JSON file. So look, I'm going to open our JSON file here. And we'll open it in Notepad. And we'll just use something simple here. There, Notepad. All right, so I want you to look at the syntax of this JSON file. It's identical. You see that? Look, let's go look at our dictionary right here. Scroll up a bit. Look at our dictionary. Here's our dictionary. See how it's defined? All I did to create this JSON file, this is how perfect the syntax of a dictionary is for JSON syntax, right? All I did is I took this section here, minus the semicolon, and minus the variable here, and the assignment operator. I took that whole section there, I copied and pasted it verbatim into this text file. Other than that, I didn't change a thing. And there's my JSON file. And I can read that data in from my JSON file and display it. Now, instead of running this function, we're running this function. And we're reading that data in from a file, right? Here's our JSON file. And I showed you how it's, the syntax is identical, the dictionary syntax to JSON syntax. But if I display it, if I parse it and convert it to a string to turn it into a table, let's hit F5 and run it. And look, it's the very same thing. Only this time I'm reading the data in from that JSON file. And this time I'm reading the data in from that JSON file, see? But the syntax is identical. So how cool is that? And we're done with that CSV. Let me close that too. So very, very wonderful, cool capability of a Python Panda object, not just to read CSV data and manipulate it and save or write to a CSV, but also to read JSON data and manipulate it. Next, let's take a look at Python Panda's ability to clean and manipulate data and reorganize data, things like that. So we're going to take a look at the drop NA method that you can use with a Panda. Let's say that we had a data set with empty rows and we wanted to get rid of those empty rows, garbage in, garbage out. We wanted to clean up the data because we had all these empty rows and things inside of it. Well, to emulate that, we're going to create a CSV with some bad data on purpose, okay? So let's take a look at our CSV file here, bad data 01. All right, and we're going to use read CSV to load that data. And look, here we've created some bad data. So in our rows, right, remember that the first row is always our variable or our column names, but then after that is our records and our record set. We've got some null values here, right? We've got some empty data in our columns. So that would be bad data. And let's say we want to get rid of that, all right? So we're going to open the CSV. We're going to, and then on that Panda object, on the original data frame, we're going to call this method drop_NA, okay? And drop_NA, it'll remove rows with empty cells, okay? And by default, it returns a brand new data frame and does not change the original. And that's for safety reasons, okay? A lot of times you want to maintain your old data set and create a completely new data set. But we'll do that in this instance, and then we'll also look at how to use nplace equals true. And if we supply that as an argument to drop_NA, then it will modify the original data frame. But let's do that here. And we're going to display it. And we have to parse it. We have to convert it to a string, right, to print it, the value in the print method. We'll do before and after, but the way we'll do it, we'll display the original data frame. Nothing was done to that by default. And then the new data frame, modified data frame, we'll display that and see what effect drop_NA had on those rows that had the columns with empty data. Okay, so let's hit F5 to run. And let me pull this up here so you can see what's happening. Okay, so original data frame, look, here are our rows of data. You see where NaN is displayed here? That's where we have empty values. So we have bad rows, we have bad records. And if we want to clean up this data and get rid of those invalid records that don't have a required field value, then we can use drop_NA. So after we call the drop_NA method, creates a new data frame, and then we can display that with our Panda. And look, only the records that didn't have missing data in their columns are in the new data frame in this instance, okay? All the ones that had missing data are gone. And these are the only ones remaining. Now, that is the default value or the default behavior of drop_NA. If you don't supply the argument, the nplace equals true, it doesn't modify the original table. Creates it, you need a new table, a new data frame. Now, let's look at supplying the argument nplace equals true. We'll actually modify the contents of the original. And let's go down here. We're just doing the same thing here, but notice that our syntax and our logic is a little bit different, because now instead of maintaining the data in the old data frame and storing the changed results in a new data frame, we're doing everything to the original. It's writing back to itself. Potentially a bit more dangerous operation, but it's there as an option if you want to use it. So the syntax for that, look, I'm going to display the original data frame and then just one line of code. And using the same object, I'm going to remove the empty rows using drop_NA, pass an nplace equals true to modify the object itself instead of a new data frame. And then I'm going to display it afterwards after the changes have been made. So clear the screen and let's run it. Look, original data frame, empty value, and the attack column, empty value, empty value. So 3 invalid records out of our set of 7. We're going to remove them all. And now look, we have only 4 records remaining, the ones that did not have empty values in that column. So a very useful method, yes? Let's take a look at another example here. And let me go find this method. Okay. Now, let's say that we don't want to do an entire table from our data set. Let's say we want to target a particular column. We can do that with this, the argument subset. Okay. So here, subset equals attack. Then in this case, I don't want to clean data from any column in that table. I just want to target specifically the attack column. Okay, so that way I can be a bit more careful. I don't want to inadvertently remove a row if it's not a column that I'm trying to clean. So to specify a specific column, in this case the attack column, this would be the syntax. And again, we're modifying the original data frame itself, so emplace is equal to true. So if we run this method, targeting the specific column attack, same results, but let's say that we also had invalid data in another column. Let me do that. Let's go break this even more here. All right, let's say that I had some more invalid data in this column and in our health column. Okay, so we'll do that. Let's save it. And let's run this method again here, F5. Okay, even though I also had a null value here, notice that it ignored it for USAP. Why? Because I specifically targeted only one column. I specified it with the subset argument, and I supplied the name of the column, attack. And that corresponds to here, right? Attack. So it's our third column, our third field value here. But and I'll add that data back there. Okay. Okay, let's go look at our next example. Now, we looked at drop NA for dropping and targeting specific columns, but what if you don't want to remove a row? Let's say that you just want to replace bad data. So you have some data, but it's invalid, it's garbage, and you want to modify it or change it to some other value. Well, you can do that with fill NA, and it also accepts the argument emplace equals true. You know, if you don't want to do a new data frame, if you want to modify the original data set, a data frame, supply the argument emplace equals true. And what we're going to do, we're going to load the same CSV, and we're going to look for, in this case, emplace equals true, and fill NA. If we find an empty row, instead of deleting the row, let's just replace it with the value 444. So we'll display the data frame before, the data frame after. Let's convert it to a string bit. All right, and again, here's our CSV data that we're reading. So take a quick look at it. Look at our rows, look at our columns, and let's go look at before and after when we run this. Okay, so look, we have some empty data here in this row, here in this row, and here in this row. So for Zoro, for Nami, and for Chopper, we're missing attack values. Okay, so what do? Using fill NA instead of drop NA, we just replace those empty values with 444, 444, and 444. So just an illustration of, it's sort of like drop NA, but fill NA, instead of removing that record, it allows you to replace the empty value with a value that you specify. In this case, we specified 444. In this next example, let's look at a Panda object's ability to clean up some bad data that has the wrong data type. So again, here we have Panda bad data 2, and I've intentionally put data in the wrong format here. So string, not a date format, or a whole number integer format, but we have data that's not in the right data type. So can we clean this data? Can we correct this error? We're going to use toDateTime to typecast, right? Or convert that data from the wrong data type, be it integer, be it string, to an actual time date object in Python. So we can use the toDateTime method to do that. And we're going to do this reflexively, meaning that we're going to do it on the object itself. So I'm going to take a column of data, a whole column. In this case, this last column, the join crew date. I specify it here, right? And then in my Panda, I'm going to pass it in to the parameter as a parameter to the to_datetime method. And I want to use this option, format mixed, because I have different errors here, different data types that are wrong. So let's look at before and after when we run this method. Hit F5 to run the function. All right, so look, before we have different data types, right? Datetime, integer, string data. That's before we did our casting with to_datetime. But afterwards, look, now the string data, the integer data, it's all in the proper date time format. So that's just an example of Panda being able to clean up data type errors that you might have in a data set. Let's look at targeting and replacing specific bad data, all right? So if I wanted to, I could use the loc method, location, and specify. In this case, I want to target health, okay? And location too. The health, so for my key value pair that I read in, I want to target, let's look at rows here. We're loading bad data. Oh, got the wrong file. Let me open the right file that we're reading from here. Okay. All right. So look, in this case, we're targeting health, right? That's our second column, right? Remember the first row, it's not an actual record, it's the column names, right? The variable value, or the variable names in our table. So in this case, the second column, health, I'm targeting that, and then which row? So this is the first row, Luffy. This is the second row, all right, Zoro. And then I'm targeting health, so he has health 5,000. What is his health going to become? 42. We'll specifically modify that to 42. So let's run this, we'll read the data, and look at before and after and see what changes are made. Hit F5 to run. Okay, so Zoro was 5,000. And oh, Nami, oop, off by 1. There you go. Yeah, I want right, this would be indexed as 0, 1, 2. All right, so 2 is actually the third row, not the second. See, I still get hit by off by 1 errors all the time, but it's just something you have to kind of train yourself, in your mind. But so in this case, Nami was 750. Now Nami is 42. But see how we targeted? We specifically targeted the health column, and we specifically targeted row 2. But because we started 0 in that fence post, 0, 1, 2, that's the third row. So look, 0, 1, 2, Nami, that 750 here became 42 here. So we can specifically change or modify a specified value using the syntax and the location method, okay? That was a specific row, but what if we wanted to do all bad data in a specific column that matched a certain value? And let's say that we wanted to replace it with another value. And let's say that we wanted to use a decision structure and say if it was greater than or less than, or within a certain range, maybe we had some nested if-else structure. Well, we can do that too. Again, using the location method, again, specifying the column name, but we're just going to use a for loop. We're going to iterate through, and in this for loop, we're going to look at, row by row, we're going to say, look, if their health value is greater than 3,000, change it to 444. So this for loop here, look, we're going to go row by row from Luffy all the way down to Usopp. And we're going to look at their health values. And if it's greater than 3,000, so yes, Luffy, yes, Zoro, yes, Sanji, yes, Robin, we're going to modify it and change it to 444. And we'll display before and after. So A and B, before and after we make these changes in our repetition structure. Just like any other iterable, right? We can process it element by element. So let's take our panda. We're going to run this, F5 to run the code. And look, all right. Here are our health values, and they're greater than 3,000, okay? So 9,000, 5,000, 4,900, 6,000. All right, so we have 4 instances that would match the test condition here if that location in the health column and then that element has a health value greater than 3,000. So this is before. Now let's look at after. Again, look, 444, 444, 444, 444. So every instance in before that was greater than 3,000 has now been replaced with the value 444 here. So just another way that a Panda can help you manipulate and clean and refine data sets. In this case, the data that we read from that CSV. Now let's look at targeting and dropping all bad data in an entire column, okay? And in this case, we're going to use the drop method. And again, we're going to use the end place equals true. So we want to modify the object itself. It's reflexive. We don't want to assign it to a new object, but we're modifying the object itself. We're going to target the health column if it's greater than 3,000. And what are we going to do? We just want to drop that record. All right, so let's look at before and after. Clear the console down here. Let's hit F5 to run. Okay, so look, everywhere where we had greater than 3,000, let's look where that condition matches. And in the health column, 9,000, 5,000, 4,900, and 6,000, they've all been dropped. The only remaining rows are the records that we had, the rows that we had, where we had a health value that was not greater than 3,000, right? So just an example of using the drop method and location to target items in a column with a specific value. And then if you want, you can modify and change them, or you can drop them, just get rid of them completely, but only in that one column. Now let's look at duplicated and drop duplicates. 2 very useful methods to deduplicate your data. A lot of times you have duplicate records that are identical. You don't need that. You want to deduplicate and get rid of those. So drop duplicates is a very useful method to do that, to get rid of duplicates that you have in a data set. And if you just want to tell whether or not you have duplicates in a data set, the duplicated method will return a Boolean, a bool, true or false, whether or not there are duplicates. So we're just going to show that. In A, we're just going to display if there are duplicates in our data set. And if there are, then here, we're going to drop those duplicates. And this will be on the data set, the data frame object itself, our panda. And then we're going to display, again, whether it's duplicated or not. Okay, so let's run this code here. Clear the console, hit F5. All right, so look, are any rows in this data frame duplicated? So 0, 1, 2, 3, 4, 5, 6, 7, or 5, 6, all false. We get to 7 and 8, it's true. Why? Where is this data coming from? Panda bad data 02. So let's go open that and take a look at that column, those columns there. Panda bad data 2. Let's open it with Notepad. All right. So are there duplicates? Yeah, look. Here's Nami. And here's Nami again. And here's Nami again. We have 3 Namis, and they all have the same stats. They're identical. We only need 1 Nami record. We don't need 3 Nami records. That's just garbage in, garbage out, right? Giga. So let's clean this up. Let's deduplicate our data set that we read from the CSV. So the first time we call duplicated, look, this is the first time we've encountered NAMI, so it's false, all right? So 0, 1, 2. But then the last two NAMIs here, indexed to 7 and 8, well, we've already encountered a record that's has all these values, right? So this is true, and this is true here, true and true, okay? So then we're going to call drop duplicates. We want to get rid of those, and now instead of having 8, we only have 6, and look, they're all false now. No more duplicates. We only have one NAMI now, which is what we wanted. These two rows here were dropped from our data set because we called drop duplicates. So just some of the many methods and functionalities of Panda objects in Python. Pretty cool, huh? In these next few examples, we're going to take a look at a Python Panda's ability to analyze data in a data set. So the first method we're going to take a look at is core, right, for correlation. And it will just give a numerical value based on the relationship one column has with another. So let's say there's a 1-to-1 relationship. So each time a value goes up in the first column, another value goes up in another column also. In that case, it would be like a +1 or a variation on that. Let's say there's a negative relationship such that each time a value goes up in one column, then the value goes down in the next column. Then that would be like a -1 value. And let's say there's just something like 0.2. Well, there's not really a good relationship at all between those columns of data. There's no correlation. So just a quick way of analyzing different columns of data. And let's take a look at our data file real quick that we're, all right, so we're going to be parsing and analyzing and correlating the data in these columns, health, attack, and defense, for again, for our one-piece cast here, okay? So if we run this method, F5 to run the function, okay? And look, so here we have a 1. So there is a correlation, in this case, between, the health column, and we have attack and defense, but then here we have 0.4 and 0.6, no real correlation there. And this is just giving sort of a relationship equivalent represented by the numerical value. So one thing you can do, just one of many different ways to analyze your data. And this is using, in this case, in addition to a Panda, we're going to use matplotlib and pyplot. We want to import that module as the plot. But that's built in. If you've got Anaconda, you've got that. Just import it. And then look, we're going to instantiate a Panda object from a CSV file from that data, right? Make a table of data. And then we're going to take that, our Panda, and we're going to call plot on it. And then we're going to call the show method to display that data. So if I hit F5, just a quick way to plot that data, graphically represent it. Okay? So again, let's look at the data. I'll pull that over here, right? So health, attack, and defense. And there are the numerical relationships. Okay? This time, we'll scatter plot, right? So just a different type of display here, but still with our Panda. I'm going to hit F5 to run it. Okay. And again, comparing that to our data, and this is just a scatter plot. And I did that by using the kind argument and specifying scatter. What if, on the other hand, we wanted a histogram? In this case, I'll use the kind argument and specify hist for a histogram. I need to comment this method out, and let's run our histogram method. So if with kind I specify histogram, let's see what happens now when we run it. All right, so here's our histogram, and again, here's our data right beside it, health, attack, and defense values. And then what if you want to create, say, a histogram based on one column? I could do that if I argument or pass in the parameter this way. So here's my Panda object, the data that I read from my CSV, but this time, instead of the entire Panda and the whole table, I'm just going to pass in the health column and then plot, and then I use the kind argument to specify hist for a histogram. So if I do that, okay, running this last method here, let's take a look at what it's like on just one column. All right. There. Okay. So I hope you enjoyed this video. My goodness, I have barely scratched the surface with Python pandas. There's so much to them. You could just spend eons going over all of the functionality and getting into the depths of pandas. But I hope this was a nice, brief, cursory overview or introduction to the Python pandas module and some of the many amazing things that it can do for you. If you enjoyed this video, please click subscribe and hit the notification bell. And I want to make another one, you'll be notified. Thanks for watching.